I'm looking at this JVC portable VHS recorder. In the previous video I'd got it to the point where it's accepting a tape and loading it up and playing it, but it's running too fast. So I'm now going to have a look at the capstan servo and try and figure out why that is. This is the capstan servo. There's two loops, a speed control loop and a phase control loop. This is the speed control loop. There's this frequency gear on the capstan flywheel. That produces a 126 Hz wave when the capstan's running at the correct speed. That goes to this chip, which is a frequency to voltage converter. The voltage it produces is inversely proportional to the frequency. So as the capstan speeds up, the voltage going to the non-inverting input of this op-amp decreases so as to decrease the drive to the motor. It comes to a stable condition where the motor runs at the correct speed and the output voltage stays constant, and that's the free running speed as set by this pot. The other loop is the phase control loop, and that's mostly in this chip. We've got this 32.768 kHz oscillator, which is the reference. In play mode, that's divided down to 25 Hz. It's then formed into a trapezoid waveform, and that goes to this sample and hold circuit to be sampled. The sampling signal is from the control head, that's also 25 Hz. It goes through a monostable to delay it, and another monostable, and to the gate input of the sample and hold. How this works is that under stable conditions, the voltage from the trapezoid will be sampled about halfway along its downward slope. That voltage is held by a capacitor, and it goes to the inverting input of this op-amp to drive the motor. If the capstan slows down, the sampling pulse from the control head arrives late, which means it will be further along the downward slope of the trapezoid, and the voltage stored on the capacitor will be lower. Because it's going to the inverting input of the op-amp, that means the drive to the motor will increase to speed it back up. And conversely, if the capstan's too fast, the pulse will arrive early. The sample voltage will be higher and the speed reduced. This is the actual circuit. This is a speed control chip. The frequency gear signal comes in here. It's amplified again, and it goes to this sample and hold circuit. This chip works in a similar way to the other one by sampling the voltage from a sawtooth wave. This is the circuit that creates the sawtooth, and that's sampled and output at pin 10 and goes to the op-amp. We can test that by checking the FG signal is there, and if we can slow the capstan down, we can see if the voltage at pin 10 responds. This is the phase control chip. The control track actually comes in here, amplified by X12, then to this monostable in IC6. The output of that goes to pin 4 of IC1, so we need to make sure that that's there. The oscillators here, that's divided and integrated within the chip, and we have test point 5 that shows us the trapezoid with the sampling pulse superimposed on it. Pin 25 is the output drive voltage. Now have a look at the speed control chip, it's IC13. So pin 1 is the input from the frequency gear. I don't know if it, can't really see much. Go to pin 3, which is amplified, yeah, you can see it there. And pin 6, amplified again, square wave. And that goes into pin 15. At pin 12, that's the sawtooth ramp wave. There is one, and sampling, which I think is at pin 13. Yeah. pin 10 is the output voltage, so I need that DC couple. We're to 2 volt, it's at 4 volts. Now I can't get to the flywheel because the boards are in the way, so I'll see if I'm stopping it and nothing happens. Seems to be at that, so I don't know, it could be this, but we can go on to the phase control loop and have a look at that, and then if that seems to be in order then we can come back to that. Right, so the phase control loop, test point 5, that should give us the trapezoid and the sampling pulse. Doesn't seem to be a sampling pulse, just the trapezoid, right. So the trapezoid's from that comes from the oscillator, and the sampling pulse comes from the control pulse, the control head off the tape in playback. So that comes in at pin 4. Nothing. So where does that come from? Oh, test point 13, where's that? Is IC6, and test point 13's here. There's no there either. That's it after the delay from, that's the output of the monostable, like the delay. The input to that is test point 12, which is like the collector of transistor X12. Nothing there about the base. That's a collector. Base is just I. That's amplified for that in IC5. Test point 11, that's right over there. Pin 3 of IC5. There's a note there. The input's pin 1. That note there. Well, they won't be able to see it, would you? Because it's at that size. Because this is a signal from the control head. Kind of difficult to tell. It looks like there's something there, but if I put it on thingy, not sure if that's just noise or what. I'll see if this is amplifying. Put my finger on. Turn this down. Yeah. So I can get that to amplify noise from my finger, so it is amplifying. So what, there's no input from the control head. Where does that come into the board? Over here, 218, which is this. Still like the same. That on the other side. Same. And where does it go? And the audio board. It's terminal 91. 91 is this. Right. So is that thing plugged in? It's not come out when I've been taking boards out and stuff and just not put it back in, has it? We'll stop it and have a look. It looks like it's hitting. So another thing's just broke there as I picked that up. Capacitor has come away. Put soldering iron on. Fix that. This is that terminal with 91 on it. We're in. I'm gonna have to go through with buzzer. It'll be one of these. Not sure which one though. 91. So that is connected. Right, so that thing is connected directly to IC5 pin 1. Yeah, there's no there, but the chip does work to amplify. So what is it, the head? Surely not. Unless in moving it about, I've like remade a dodgy connection or something. Try putting it back together again. I'll get another try. Let's rewind this back to the start to make sure that we're on a bit that there is something on. That's another thing, this is taking a long time to do that. I think it's like the reset pulse for the controller. Just check this reset pulse. Let's stop now. Alright, start it up again. This is pin 3 of IC5. There's nothing there. 4, 5, 6, pin 6. That's still not there. So what? There's just no pulse from the control lead. I don't know, I mean, like, find it hard to believe that the control lead itself has failed. If there are no control pulses, there's that detector circuit to detect that there aren't any, to connect and override it. This circuit detects whether the control pulses are present. In playback, the pulses keep this transistor X38 turned on, which charges up this capacitor C100. That keeps this transistor X39 turned off, so this diode is reverse biased. If the pulses are removed, X39 turns on, and the voltage here goes high. That goes to pins 12 and 13, which closes these switches. This one connects the midpoint of this voltage divider to the output, and that sets the speed of the motor along with the speed control loop. The other switch connects these two capacitors to the same point. They're normally connected as part of the loop, and it's to keep them charged. So we should have this happening, so even without those control pulses, it should be running at roughly the right speed. Right, so let's have a look at what's happening with this pulse detector circuit. This is the test point for it. So yeah, that's gone high. So in pin 11 of IC14, that voltage, and that should be connected to pin 10. It's the same voltage, and then that goes to pin 4 of IC15. 1, 2, 3, 4, and that is the same voltage again. So that must be putting that voltage on there, which is what it should be doing. So let's have another look at the speed control. So if I look at pin 10 of IC13, this is like the output voltage. If I slow the thing down, I'm just sticking something down between boards to catch the flywheel. Nothing's happening there. Now that's pin 12, which I think is the holding capacitor. Pin 13 and 9, 10, 11, 12. Pin 13 that's got these pulses on it, but I think that should be the sawtooth wave, because that is connected to the free run adjustment, which is going to adjust like the slope of the sawtooth. So where's that go to? I'm going to have to trace it out on the thing. It goes to this C89, and well, this is the thingy. This is the pot. Just got that on it, and that must be that resistor. It is connected. It's another lifted pad. Press that pad down and I can hear that slowed down. Lift it up and it goes fast again. Wonder if this thing comes back, if these pulses appear when that's pressed down. It's still, is it still running in that free run mode? Yeah. That's one thing at least. If I resolder that, then it should be running at roughly the right speed. And then we've still got a problem though, because there's no control pulses. So I'll resolder that, and I'll resolder that other capacitor that came off. I also spotted this capacitor that was hanging out of there. That one, it come out of that hole and it was lifted up from that one, but there isn't enough lead on that side, if you can see it there, to put it back in, so I'm just going to replace it. Right, so I've resoldered them joints. I spotted a couple of other components that were a bit wobbly, and same thing had happened to them, so I resoldered those as well. It probably wants the whole board resoldering really, in terms of like long-term reliability, but I'm not doing that, or not now anyway. But anyway, let's try it and see what it's like now. It's takes a long time to start up, which I think is the reset pulse. It'll probably stop as soon as I try and look at it. That's a reset. It goes high to put it in reset, and then it goes low to, you know, to go back into normal mode after being reset, and it's just staying high there. I think the timing capacitor for that reset, it's an electrolytic, I think, so I'm gonna have to replace that. Alright, so it's come out of reset now, so we can try it. Starts up alright. Oh, that head drum's taking off at a fair speed. What's it doing? Switch it off. I don't know if I've caught something there, but that head drum just started going off at full speed. And we're back in reset. Right. Oh, it's in play mode now. It sounds like it's running at a reasonable speed. Let's have a look at the. So that's the sawtooth for that speed control chip. That's the output voltage. See, that's more doing stuff now, and it's at 2 volts instead of 5 volts. You can see it's actually moving up and down. as you would expect, you know, slightly controlling speed. Now what about the control pulses? So test point 11, it says test point 11, but like you never see anything there. So what about, is there any control pulses? Or are we just in that free running mode? So this is pin 3 of IC5, which is what it says test point 11 is in the schematic, but then test point 11's over here and it doesn't seem to be connected to it. Well, unless there might be a jumper going across maybe. I can't see anything on that, but we are at least getting the thing running at the right speed. Right, put that there. I press down on this board, that comes in. I don't know if it's this connection here. Quite possibly. Might be more resoldering. I'll try resoldering it, some bits of this connector or all of it, and see how that helps, if it improves it. But I think again this is one where I did resolder it but it's not taken very well, so I think I'll just desolder, just remove what's there and just put all like fresh solder on, and then hopefully it'll be alright. Okay, so resoldered all that lot, so try again. That looks pretty good now. Messing about with board doesn't seem to affect it, so hopefully that's alright now. Right, so let's see what it looks like connected to a telly then. And before I try it out connected to a telly, I want to replace this capacitor C70, which is the timing capacitor for the reset circuit. There's also this other capacitor here which has got quite a bit of green on the legs, and that's the decoupling capacitor for the Zener diode of this 10 volt regulator, so I'll replace that as well. State that. Right, let's try the machine now and see what it's like. And what on the fault? It seems like there's still fault with the servos. It seems like capstan servo, I think. That looks like capstan servo. And what I did all of these sounds a little bit slow. These voltage. That capstan belt's not in a very good state though, so I'll replace that and then try it again because it might just be belt. I've not got the specific belts for this machine, so I'll just have to see if I've got one that fits. I should hopefully have one. See that? It's quite loose. I'll see if I've got one that fits it. And all that white in there. There's like a residue on spindle as well. See that on there? Try and clean that off. Well, I've got rid of some of it. It's quite difficult to get off actually. I think it probably wants soaking really. But got this belt that might be alright. Although I'm not sure, it might be a bit small. I don't know, might be alright. Feels maybe a little bit tight. I don't know, I can try it anyway. I don't really need to put that back on because I'm going to just be playing it upside down anyway. Right, so we'll try it again. Oh, that's not very good. I think that drum's going a bit mad as well. Whenever you do all that, you always. Well, capstan sort of sounds like it's running at right speed. I think that's drum servo going mad there now. So we'll have to look into that. That one. To go. That's a bit going slow again, that. Yeah. So I think the thing to do will be to try and set the servo up. I'll check the capacitors in the loop filter as well for both servos. They're always a bit touchy, these analog servos, like the one on the 3V22, that's like that. It's always needs resetting and stuff because they drift over time. So I think that'll be the next thing to do. So for the capstan servo, there's a few things to look at. We've got the speed control chip here, and there's a couple of caps associated with this that could cause trouble. C98, that's decoupling the supply, and C90, which is decoupling the output from the 6-volt regulator in that chip. There's also C101 and C102, which are part of the filter for the output voltage of the phase control circuit. These are tantalums. And there's the corresponding capacitors in the drum servo circuit. The drum servo is pretty similar to the capstan servo. The capacitors there are C39, C34, C24 and C25. So we'll check them and replace where necessary. As this is C98, it's one of them Elner jobs. It looks alright, and in my experience these sort of capacitors tend to be quite reliable. ESR's a little bit high, maybe. Let's see what a new capacitor looks like. This isn't like an high quality one, or it's just a cheap one. Yeah, V loss, don't know what. 0.73 ohms, that would be more like 1.1 ohm. I think it's alright, that capacitor. This is C90, another Elner. This is a decoupling on the 6-volt regulator output. 3.8, that's pretty high, that. Try a new one. No damage parts are not in right. I'll not put it in properly. In 1.4. Just like more than double that. But I'll replace that one I mean, that still might be alright, but C101, the tantalum ones, stood up with a pair of trousers on. That looks fine. And C102, same type again. Basically the same results. Put that back in. This is C39. I don't really like the look of this one. But this on underneath, and there's a bit of it on the board as well. Just here. It actually measures alright. I think I don't like the look of that stuff, so I'm going to change it. It's C34. It's the filter for the 6-volt regulator output on the drum servo. .3. Not that bad, but 2.4. It's going up. 2.5. 2.5. It seems to be staying stable now. But I'm going to change it. It's a bit high, but I mean it's probably alright, but that weight going up when they do things like that, it kind of puts me off a bit. But I might as well change it. It's capacitor, but, you know. Right, the two tantalums, C24 first. That's worse than that other one, but with that other one a bigger cap. C25. Same as other one. These are fine. Better than equivalent like electrolytic cap that I've got. I ain't got a tantalum of that size. Right, for the capstan servo, we've basically got one adjustment, which is the capstan free run speed. You put it in record mode with test point 23 and test point 26 shorted together. That puts the servo in free run mode. Then you adjust R210, which is the ramp of the speed control. You set that for minimum drift between the trapezoid and the sampling pulse, which means that the signal from the frequency gear and the one from the reference oscillator are at the same frequency when the servo is not locked. Basically the capstan's running at the right speed. You can then check it by removing the short, and the servo should lock up the sampling pulse halfway down the trapezoid ramp. You can also check the ripple across the capstan motor, which should be less than 0.1 volt. Right, so we're at test point 5. That short's in place to force free run mode, the capstan, and we can press record and attempt to set the capstan free run speed. What have we got here? Just the sampling pulses, no trapezoid. So, right, trapezoids from the oscillator, which is pins 28 and 21 on here. So that's running, but I think it weren't running when I first put it on. Pin 1. Yeah, look at that. So we've got a square wave now, but not a trapezoid. So this thing ain't running reliably. This oscillator, that looks a bit dodgy. See that? That's pin 1 now, there's nothing there. This is going to be more dodgy solder joints, I bet. I'm going to clean up these solder joints around here and try again. I think I'm going to end up having to just redo the whole board, because I don't think it's going to work reliably unless I do. But I'll clean up round here and then try again. Right, let's try again. It's nowhere near the correct speed. And this is the thing, we can break the seal on this pot. Well, there's some flopping a bit in it. Excites part a bit. That's pretty much bang on. Let's see what it's like if I do it again. Set it up again, does it come to the right speed? Yeah, it does. So that hopefully should lock up when I start using it properly. I need to look into that flapping, that I think tape's flapping. I can't see it obviously, so I've got the thing upside down, but I have to check that. Might be to do with real brakes. I don't think they're a bit dodgy, I think. So let's try it without the short circuit, see if it locks up. Oops. Yep, that looks pretty well locked. So it should hopefully be capstan alright. And then check test point 24, which is a capstan motor output. This should be 3.6 volts about, with less than 0.1 volt ripple. And then it's in record again until it gets started. This is 1, 2, 3. It is bang on 3.6 volts pretty much. Got an AC motor, pretty ripple. Less than about half a 0.1, 0.05 volts, so that's fine. So on to drum next. For the drum servo, you've got to check of the amplitude of the pulses from the pickup head. There should be a volt in either direction. The drum free run adjustment is the same as the capstan one. Then you've got things like the head switching point and other adjustments of the various monostables. The checks of the sampling pulse position and drum ripple are the same as with the capstan, except 0.2 volts is allowable for the drum. You then get into the adjustments for fast and slow playback modes, but we'll try and get normal speed working reliably before getting into that. So you need a video input for doing the drum servo. It says in the service manual, it says colour bars, but it don't really matter what the actual picture is. It's just the sync signal that it needs. So I've just plugged in a camera. It's just easier for me. And so first we've got just a check of the sync signal. That's supposed to be about 9 volts peak to peak, but that 20 millisecond between the syncs, which we expect. It's just sync from the camera, but it's all coming through properly. Okay, test point 10 to check the drum pickup pulse. It should be 1 volt either side of 0. And it is. And that looks locked to me. It's not moving up and down, it's running at a constant speed. Test point 2 drum flip flop should be 7.5 volts. And it's about 6 volts. And it should be able to be slowed down like that and be alright. So it's a bit low, well, compared to what it says it should be, but I mean, plus or minus 1.5 volts, so yeah, it's fine. Drum free run, short circuit test point 6 and 26 to put it in free run mode, and then adjust R47 for the correct speed, which is this one. Oh. They look a bit weird, don't they? Look very close together. Free that hot up a bit. Right. Do the same, pre and record. That looks, it's halfway up the slope, which is how it should be. It's the other way round from what it is on the capstan. That all looks locked. We can also check the frequency of the drum frequency gear. Put it in record. This is test point 7. Should be more than 0.8 volts peak to peak, it says, which it is, it's nearly 2. So we can measure the frequency. It's 1.5 kilohertz, which is what it should be. That's right. So we can try it on the telly again now and see how it plays back now that them things have been set up. Right, I'll test it with a tape now. That's locked up, that servo's running alright. There's a slight bit of breathing to it, or maybe a tiny bit, but it's not too bad. That's just sort of slight gradual fluctuation at drum speed where the picture expands and contracts horizontally because the length at lines is increasing and decreasing. But it's only very slight. A bit of a disturbance there. Pictures, it's alright. It's not brilliant. I don't know what they're normally like. These, what sort of standard of picture to expect from them really. Right, well I've got the remote here, so I can try slow playback mode. I'm going to go through the other adjustments for the servo to try and get it set up as best I can and see how it plays back once I've done that. Right, got the playback head switching point. So this is synchronised to the flip flop, and it wants to be 6.5 lines before the vertical sync, which is this bit here. Is this one? What's this one? 2, 3, 4. Yeah, so that's 6.5. And go to the other one. That's too far. That's that. And we've got the record switching point, which is basically the same thing but in record mode. About 9.5 lines that. That's that. This record control delay adjustment, this wants to be 8 milliseconds, I think. It should be 8 volts peak to peak. So that's about right. What is it? 1, 2, 3, 4, 5, 6, 7, 8 and a bit. Plus or minus 2.2. Hang on. Playback control delay. You make a recording and then play it back and adjust it. So I'll make a recording and then I'll come back and play it back. Right, control playback delay. This is similar. It wants to be 20 milliseconds from there to there, and I think it already is. 2, 4, 6, 8, 10, 12. Yeah, hang on, 20. That's fine. Next adjustment is the tracking preset, but I'm not going to do that because having just played back a recording made by the machine, I know that it played best with the user tracking control in the middle, which means it's correct. The shuttle search tape speed and drum speed. The tape speed is just a check. So we play back a recording in search mode and check test point 12. And this period should be, well, it's slowed down there, should be 3 milliseconds. 1, 2, 3, which it is about, yeah. And this should be less than 0.5 milliseconds, which it is just about. Well, that tape speed's very variable. So we've got the search drum speed. You play it back, adjust the pop for the best picture. Don't know how good I'll be able to get this. Yeah, that's about as good as you can get, that, I think. There's also a rewind one, which I'm not going to do just now because it's having trouble with rewind stuff, because one of the reel brakes has gone flat and it's not stopping it, so it's like leaving a loop tape out when you change from rewind to stop or play. So I'm having to, when I rewind it, stop, and then I have to fast forward a little bit to take the slack up. But I'll attempt to fix that. The slow tracking adjustment, this is another one that's done visually. Put it in slow mode and adjust R196 and R189 for best picture or minimum noise. So you need remote to put it in slow mode. You have to put it in the, there's a variable, there's a slider for the speed, so you put it at the maximum. Press play and put it in slow mode. You have the slow tracking at the centre position. R196. I can't really get rid of it. I don't know, round about there seems to be maybe at best, but it's all pretty poor. Certainly on this tape. R189. Stop now. You must only be able to do it for a certain amount of time. This is the R189, which is the preset for the slow tracking control. We're putting it, I've got it set all the way one way there, the preset, to have the tracking in the middle. To get that, then can I improve it with the other part? That's all the way one way as well, but that seems to be about the best. That seems to be about the best I can get. I'll have to see what it's like with other recordings. I'll test it with a pre-recorded thing, in slow motion. It's not actually too bad. I'm just tracking. And it moves noise bar about. Just jump a bit. That's what I'll end up tracking. If I put it, that's a still frame. The still frame's pretty good. Okay, so next thing I'm going to do is have a look at the pad on that reel brake. So first I'm going to have to got the bracket off this capstan flywheel. So I'm going to have to put that back on so it's not falling off. So these are the brake pads that I'm looking at. This one here, you can see it's kind of flattened. That one doesn't look as bad, but like that, there's no friction. Oh, that one don't really have that much friction. It's that that's giving it. So it's this one on here that needs to be replaced. This bit comes off. You see the stuff's like worn off. I'm not sure if that's what it is, if it's like leather or what. See what I can put on it to get a bit more grip. I've got a little piece of leather here off an old coat. I'm hoping if I can, might need to file it down because it's a bit thicker than that, but I don't need to file it down too much. Cut it to size, and if I can scrape that off and stick this new piece on, then hopefully that'll do the job. Right, so I made a new pad. That's that. And just have to scrape that off. See if I can get it off with this knife without cutting my sand. Or like cutting plastic too much. I'm going to use some contact adhesive, impact adhesive, whatever, Evo stick. We'll see how that goes. Put it on. That seems to work pretty well. So I'll put the cassette housing back in and try it again. Right, so I'll put it back together and I'll put a tape in and we'll see what these brakes are like now. That's left a bit hanging out. What's it like if I eject it? but that's the brake on that side. What about this side? That's nice and taut. I wind it to the end of the tape and try it going that way, because when there's more tape on it, it's got more momentum, it's harder for it to stop, which is why that's hanging out. But that's now not, so it has improved it, because before that was still leaving a loop of tape out even with a low amount of tape on like that. But I wind it towards end and see what this one's like. Right, so this is the end of the tape. That is leaving a loop out. When I start rewinding it, it kind of loops a bit out and then picks it up. And it leaves a bit out. I'm not sure whether I need to change the other pads as well, or if it's to do with the tyres on the reels, whether they've not got enough grip, need replacing. I don't know if I've got ones that'll fit it. What I could do is try taking the tyre off and seeing if I can sort of buff it up, or you know, kind of roughing it up to get a bit more grip with a bit of sandpaper or emery paper, fine grit. So it has kind of gone a bit smooth and shiny. Alright, so I've sort of sanded that down, so hopefully having a fresh surface will give it a bit more grip. And what else I think I might do is just clean out there where it sits, just get a cotton bud with some alcohol on it just to clean it up in case it's like a bit greasy or anything, and hopefully that'll grip better as well. Feels like there's something on there, like glue or something, like as if it were glued onto it, but I don't think it would have been. I'll do the same thing with the other tyre and then come back and try it again. Right, try it again. Not doing anything. Going into alarm mode. These were sort of touching like that, so I kind of just flexed them a bit. Try and keep them apart. Hopefully that'll be alright. And that's a bit further apart than what it should be really, but as long as it works. Try again. Still leaving a loop out. Making a bit of a noise as well on there, but I don't know, it probably needs new tyres and new pads on the other ones. I mean, I can do the pads, but I don't think I ain't got tyres that fit it. I've got this rubber stuff here, like a sheet of sort of rubber. I'm going to try using that as a brake, take that piece of leather off and put that on. Right, there it is with a piece of rubber on it. I ain't changed that one, but I'll see how it works and I might do that one. That's immediately a lot more friction there than what there were with the other one. Yeah. Oh, that seems to be working really well. Not leaving any tape out. I'll wind it back to the start and try again, because I think that'll still be leaving tape, and I might scrape that off and put rubber on that one, and they're both the same. Yeah, so it's leaving a loop out. So I'll change that one for rubber as well. Right, so I'll replace that pad with a rubber one. It's not leaving it out. It's not leaving a loop of tape out in either direction now. Right, now that we've got it all working properly mechanically, have a look again at the picture. A test card video. That's quite poor. It's worse than what it were before, I think. This smearing. As you can see, this smearing on things, which that weren't there before, but this sort of thing where these like kind of lines next to things, I mean, that's some amount of that's to be expected, but not as much as that. This is through the RF, and tracking's more or less in the middle. Put it on, that's through composite. That's very like white and washed out. So I'll have to look at the video signal and see what's going on. Right, I think I must have been a bit heavy-handed with this leaf switch earlier. Either that or it was about to fail anyway, because I've just gone to try and use the machine and it wouldn't start. It was going into alarm mode again. So I've lifted servo board up and found this one leaf of the switch has fallen off. It's broken right where it enters the plastic, so I won't be able to repair it. I'm going to have to replace it. I found some that look like they'll fit, but they're coming from China. I couldn't find any that looked suitable available in the UK, so I've ordered them, but now I'll have to wait for them to arrive. Hopefully when they do, they'll hopefully fit. Right, so these switches have come. This is one of them. It does look like it'll work, I think. Looks about same size as other one. I'll remove that and put this new one on. I'll have to desolder it from there, and this wire is soldered to like a tab on this plate. Hopefully that will be alright. See, it's a little bit close to that other thing, but I don't really want to bend it too much in case it snaps. See how that does. Right, this thing with the brightness being too high on composite seems to be caused by that Philips telly that I was using. I've tried it on this Hitachi one and it's okay. That's the RF. That's the composite. Now, other TV, it's one that I repaired recently. The input was blown and I replaced the IC, but there must be some other problem that I've missed. Although I didn't notice it when I was testing it at the time. I'll have to look into that. I don't know what was causing that smearing effect. It's gone away for now, so I'll have to just try and catch it if it happens again. Hopefully get a signal on that I can look at better on the scope, like colour bars or something. In the meantime, I've been having another look at Television magazine, and there's a recommendation in there for improving the picture quality on early models of this machine. It says to change C64 to 22 microfarad, R52 to 180 ohms, and replace R62 with a short. Right, now I've managed to find another PDF of the service manual. This one does include the luminance circuit, although the quality is not as good as the other one. If we look at the circuit, C47 is here. This circuit takes the demodulated video from this chip and filters it to remove the carrier and does some equalisation, as well as inverting it because the signal out of the demodulator is upside down. Now C47's coupling that to the next stage. On the schematic, the value is given as 33 microfarad and the change is to 22 microfarad. R52's here. It's part of the emitter degeneration of this common emitter amplifier. Emitter degeneration's type of negative feedback. It reduces the gain of the amplifier. In a circuit like this, in general, the gain's set by the ratio of the collector resistor to the emitter resistor. If you imagine this circuit without these inductors and capacitors, and with this end of R50 connected to the supply, then you've got a simple common emitter amplifier with a gain of about 22, which is the ratio of R50 to R49. So what are these inductors and capacitors doing? Well, they're what's called resonant circuits. The impedance of a capacitor decreases as frequency increases, and the impedance of an inductor increases as frequency increases. When you've got two of them together, there's a point where the impedances cross over, and that's called the resonant frequency. So what happens at that point depends on how they're connected. If they're in parallel, the overall impedance becomes very high. If they're in series, it becomes very low, like a short circuit. So in this circuit, with this resonant circuit as the collector load, at the resonant frequency, the gain of the amplifier becomes very high. With the emitter circuit, at frequencies other than the resonant frequency, the impedance of this path is high. So it's like there's only this path. And the impedance is 82 ohms. At the resonant frequency, this LC circuit becomes like a short, and the impedance becomes these two resistors in parallel, which is about 37 ohms. So again, the gain increases. Changing R52 to 180 ohms makes that overall impedance about 56 ohms. So the gain still increases, but not by as much. The resonant frequency of the emitter LC is about 2.2 MHz, and the resonant frequency of the collector LC is about 3 MHz. As for replacing R62 with a short, I couldn't find a datasheet for this IC. I presume this is part of this noise clip section, but what effect shorting R62 will have, I don't know, because I don't know how it works. We'll have to try it and find out. This is a luminance board. Most of the components, well, all the components are in this area. That's R52, C47, and R62 is under this capacitor. So I'll replace them and try it again and see if it makes any improvement. Right, the resistor I'm putting into it bigger than the one that was there before. I think they're 8th watt ones, this is a 4 watt. C47. That's this one. This is R62. I don't really need to take that out, I can just put a link across it on this side. Right, that's the changes made, so I'll put it back in and see what difference it's made. Right, so this is it after them component replacements. I think it's made a very slight improvement to the noise around these edges. It's quite subtle though. You see these edges, they're being sharpened, but they were being more sharpened before, I think, and it was sharpening the noise as well, increasing the noise, which is, there's still a bit of that, but I don't think it's as bad as it was. This is it on AV, and it's not too bad. Right, I'm going to call it a day now with this video recorder. It's working quite well now, and I want to move on to other things. If that smeariness fault comes back, then I might do another video. So I'll put it back together now. Right, well that's that. It's been a pretty long-winded one. There's been some interesting faults and some annoying ones. I think the main thing to remember if you're working on one of these is to keep an eye out for bad solder joints, especially on the servo board. It's possible that repair could have been expedited by just doing a blanket resoldering of that board, but I think it's more interesting to look at the circuits and trace the faults. No, anyway, thanks for watching, and see you next time. Bye.